and we're done. In this next one, in problem A, we're going to look at copying this down first. Is we've got 8 plus 3i plus negative 7 minus 2i. What most students easily forget is to notice that there's an operation in between these two set of parentheses, is that we are adding. And remembering that whether it's i's or x's, whenever we're adding, all we're going to be doing, or subtracting that is, we're going to be combining like terms. So whether it's you're adding or subtracting, all we're doing is combining like terms. Meaning numbers get added with numbers, imaginaries get added with imaginaries. So we're just combining like terms whenever we add or subtract. So in this first one, we're told to add. We can only add the 8 and negative 7 because those are the only two normal numbers. So 8 added to negative 7 is going to give us a positive 1. And then we can look at adding, let's see, the positive 3i and the negative 2i, which is a 1i. And just like with x's, whenever we have a 1 out in front of x's, we normally don't have to write it. The same thing goes with i's. So we're going to rewrite this answer as 1 plus I, and that's our final answer, and that's exactly what we would enter into our MyMathLab. Now just use the I letter on the keyboard. The MyMathLab will know the difference, and that's an I stands for imaginary. On problem B, let's see, we have negative 7 plus 9i minus negative 2 minus 8i. And with subtraction, it's going to be the same idea. It is still going to be combining like terms. It's just going to be a little bit different because we do have to worry about the minus sign. What does the minus sign do? It throws a little bit of a hiccup by making sure that we distribute the minus sign to everything that comes after it. So the first things, the negative 7 and the positive 9i will stay the same, but distributing that minus sign will actually turn my negative 2 into a positive 2 and my negative 8i into a positive 8i. But then once I do that, I can just combine like terms normally and realize I've got a negative 7 added to a positive 2, which will get us a negative 5 to start out. And then combining or adding my I terms would be a 9i, and an 8i will be a positive 17i. Be careful, I cannot add the negative 5 and the 17i because they are not like terms. But that is my final answer, a negative 5 plus 17i. It's not an equation. You can't do anything with it. All you can do is combine like terms. And just as kind of a side note, do notice that all the problems will say that they want our answers in a plus bi form, which all they're trying to say is they want the I at the end of the term. So, and if you don't do that, MyMathLab will mark it wrong and will make kind of an odd cryptic statement that says, basically, you're not wrong, but you're not right, and it's just because it's in the wrong order. Let's take a look at C. In C, we have, let's see, a negative 9 plus I minus 5i plus 2 plus 7i. Let's see what we can do here. Now, I'm not worried about really the parentheses here. They're telling me that I'm adding and subtracting. The only way I'd be concerned is if in front of this last set of parentheses, if there was a minus to distribute. But because there's a plus, I don't even need to worry about the parentheses. I can even just drop them if I want. All I'm going to be doing is combining like terms. Well, I have a negative 9 is my only number that I can add with this positive 2. Well, negative 9 and positive 2 will give me a negative 7. Then I can add up all my i's, which there are quite a few of those. There is, let's see, a positive I, a negative 5i, and then a 7i. Well, let's see. I added 2, the negative 5i will give me now negative 4i. Then if you add 7 more to that negative 4i, I'll get a positive 3i, and that's it. I can't add the negative 7 and the 3i because they're not like terms. This is my final answer. Let's take a look at problem D. In problem D, we have 8 plus 7i minus negative 7 minus the square root of negative 64 plus 3 minus I. So what I can do here in D is I can work on dealing with the square root first. We have the square root of a negative 64. Well, if I go ahead and simplify that, the square root of 64 is an 8. The negative underneath will come out as an I. We always want to do that first if we can. So we've got an 8 plus 7i. That will stay the same. With the second group, though, here we have a negative sign out in front. So we need to distribute that negative sign. So the negative times the negative 7 will make it a positive 7. Then the negative times the negative, remember there was a negative in front of the square root, so it's a negative 8i. We'll turn this into a positive 8i. And I'm not worried about the last set because it had a plus in front of the parentheses. So the second set of parentheses here that had a symbol in front is going to stay the same because it was just a plus. So of our positive 3 and our negative I, that will all stay the same. Now I can just combine my like terms. What are they though? I've got an 8 and a 7, which is 15. Added to 3 more would give me 18. So I'm going to start out with just a regular positive 18. Then I can look at adding up my i's. I've got a 7i and 8i, which is 15i, minus 1 more I will give me a 14i. So I've got a positive or a plus 14i. And that's it. The 18 and the 14i cannot be added. Those are not like terms, so we are done, and that's my final answer. The next thing that we want to look at is multiplication. And to kind of give you an idea of what we're going to be doing with multiplication, it's kind of fair to look at multiplication with x's first and look at something like 4 times x plus 2. If you had something like this, without hesitation, most students would say distribute, distribute, and that's exactly what you would do. You'd multiply out or distribute out the 4 to everything inside, which would get you a 4x plus 8. And you wouldn't be able to add the 4x or the 8 because they're not like terms. You would just be done. And that's going to be the same idea with what we're doing here, but with i's. We just have to be a tiny bit careful because i's are just a tad different. But most of it should look almost exactly the same. Same concept, though. So let's take a look at this first problem. We'll start out with a negative 4i times 3 plus 4i. So continuing along, what we'll do is we'll take this negative 4i and do what we were doing before, which is distribute it to everything on the inside. So we'll start off by multiplying that negative 4i to the 3 first, which will get me a negative 12i. And then the negative 4i times the positive 4i will give us a negative 16i squared. However, if we were doing x's, we'd be done. But these aren't x's, so there's just a tiny bit here is we have to worry about the I squared. Remember that I squared turns into a negative 1. So I can change that I squared into a negative 1 here. And we can keep going. So what will happen is I've got my negative 12i. Then I've got my, let's see what's here, is we've got a negative 16 times a negative 1. Well, a negative times a negative is going to turn into a positive 16. And this is a perfect example of an issue that you would run into with my math lab here. Notice, if you were to type in this answer, there's technically nothing wrong with this, the negative 12i plus 16, other than they said they wanted this in a plus bi form. which means they want the I at the end. So you'd get a cryptic answer saying, not quite. So that means you need to reorder this. And we'll reorder this as with the 16, it's positive will come first. Then the 12i was negative, that will come second. So 16 minus 12i is what you'd actually want to enter into your My Math Lab as your final answer.